So recently, I've been presenting a lot in trying to identify ways that more people from non-traditional technical backgrounds can identify with some of the concepts that are taught in general Python learning and in general development. A recent study from the Electronic Software Association found that in the US, over 25% of people that play video games on a weekly basis are over the age of 30. Now, I belong in that category, and I'm assuming that a lot of people that are watching this also belong in that category. We grew up with some of these systems that now are seen as archaic devices, but we are also growing into our own where we're not just software engineers, but we truly are a generation of gamers. And while I'm not here to preach the gospel of gamification in all applications, I do think that there is some true benefit to aligning learning and development concepts with something relatable such as gaming. So for the next few minutes, we're going to look at a few different game types and some of my favorite games in those game types, and we're going to break down some of the things that we can learn in that process. But before we do that, I have a few disclaimers. One, I'm not a scientist. I know I brought up a survey, but that's most of the science that you'll hear in this talk. I'm a gamer, I'm a developer. This is how my brain works, and I don't want you to use this in any way to convince your boss that we should be playing more video games. Although if you do convince them, let me know. Also, these videos aren't me. There is one video that is me, but most of the videos aren't me. These are professionals. Don't worry, the takeaways from this talk are not directly correlated to how good or bad you are at any of these games. It's more of understanding the patterns in which are required to play these games and to play them with some level of decency. And finally, thank you to one of my colleagues, Anthony Shaw, for the inspiration in this talk. You should totally check out a talk that he gave on load balancing that used one of my favorite video games, City Skylines, as a reference and was the general inspiration for this talk. So with that being said, let's jump into the first game, which is truly a classic. And we are talking about the world of Metroid. Now, Metroid is so iconic that it actually inspired its own gaming genre, aka the Metroidvania, a mixture of Metroid and Castlevania, another game that was released shortly in that time. Where most platform games required you to go right, as we see on the screen, sometimes the benefit of Metroid was actually going backwards. You could go and utilize many different techniques that weren't originally available to you because you didn't have the right equipment or tools. And this made for an excellent idea of being able to try something, see where the barrier is, gain access to the new change, and then try it again. Now, in the development space, this is absolutely phenomenal. Sometimes we get tools later on in the life cycle, such as with Python. We gained a bunch of new tooling in the last 4 or 5 years. If we take a look at some of the things that didn't exist in the early days of Python 3, looking at things like data classes, looking at third-party modules like Pydantic, understanding maybe harder to comprehend or original concepts like enums, or even list comprehensions and set comprehensions. And of course, I would go back and rewrite most of my if-else statements with the walrus operator anytime. But we also got updates to performance. And sometimes that's the best kind of power up. Instead of trying to work away from things that are maybe a little bit easier to read, instead, we've spent a lot of time making some of those easier to read tools more performant and more efficient so that you can use them without having to sacrifice efficiency. And this is great in the development process because you quickly learn that there's nothing wrong with going back and going through your previously used code and making it slightly better using newer tools and technology. Now, one of the things that I do want to talk about with this is the level of which you are playing. Now, when you're developing, it's really easy to develop with the idea of, I'm writing this code for me. As a hobbyist developer, I spent many years writing code that I didn't think anyone else out there would be reading. This was practice for me. Now, as a professional developer or professional in the industry, I write a lot more code that more eyes are on, and that requires me to utilize tools a little different. So while it is okay to go back and make some of those changes, we still want to make sure that we're writing code that doesn't feel as if we are creating, that we're just casually playing, but more as if we're competitively playing, more like completing a speed run in many cases. But with that said, I think it's time that we then move on to the second game type, which is simulations. Now, I was going to throw a bit in on how to speak Simlish, and of course, some people may not understand how that works. But I do think that there is also a correlation in that we often look at some of the things that may seem important to us that is not completely necessary, or maybe even makes it a little hard for others to comprehend. That being said, I'm not here to lambast Simlish. I feel like it adds a very personal touch to some of these games. But I do want to talk about preparation in terms of building. So we've all played games like The Sims or City Skylines, as it was mentioned. And one of the things that I really appreciate about these types of games is that when you are creating your starting point, the starting point often can determine how deep you will go into the build that you're working on. In fact, often you have to have some type of logical starting point to move into a fully developed process. And when you're doing this, you have to think about a bunch of different things. And this is why I really love this analogy for package management. You have to think about what you're trying to accomplish versus what you're not trying to accomplish. You're going to have to think about the needs of your end user in comparison to some of the features that you would like to see. You also have to balance the idea of a quick turnaround, a quick update cycle, and the longevity of your package. Are you going to use a bunch of tools that make your project easy to build, however, haven't been maintained in quite some time and could cause problems down the road? And of course, in the world of Metroidvanias, there is going to be plenty of circling back. So how do you set up your project so that you can not only go back and make coding changes quickly, but understand the why behind making those coding changes? One of my favorite things that I often see is people building these simulation projects with a notebook next to them. I've done this in many Minecraft builds where I will have the coordinates to different things that I'm looking for and that I'm often trying to build. I'll have inspiration images saved in a document that reminds me of where I'm trying to go versus where I currently am. I feel that this is so analogous to the current developer cycle in that we often look at how others are building packages and we work to emulate what they're doing, but also we give ourselves, or we should be giving ourselves, a great head start by using templating tools such as Cookie Cutter, or even just having great documentation and testing around the different facets of our project. And speaking of templating, I think this can take us into our third section, which is probably one of the most rewarding and yet frustrating gaming types, which are racers and fighters.
That's right. But once Dogra catches him once, Dogra's offense is world class. That's right. Once again, he's caught him. Uh-oh. That's safe. Wow.
Now, on the screen, you're watching a clip from EVO, which is a video game fighting tournament. And this is actually one of my favorite games. Well, this is a game called Blaze Blue. It is super fun. And what we're noticing is there's this extremely long combo where one of the characters completely annihilated the other, and it seemed like it wasn't even fair. There wasn't even a chance to progress into it. And I have a personal story. I had a roommate at one point that was very into this game and invested hours and hours and hours into learning a similar combo to this one with that same character. And it got to the point that I didn't want to bother playing against them because I just knew there wasn't any hope for me. Now, obviously, I don't want that to be the takeaway, but I do want to look at the idea that racers and fighters in general are well known for very meticulous practice in doing the same thing a lot of times. Practice makes muscle memory. And the more that you're able to build things, the faster that you're going to be able to build those things. The more efficient you'll be able to build those things, the better you'll be able to test those things, document those things, and automate those things. Nobody learns Vim on their first opening of the tool. Nobody knows all of the different commands and workflows with Git the first time that they open it. The only way that you're able to go back to those things, aside from pulling them up from reference, is by having situations to where those things were required and you discovered how to resolve that issue. And in the development space, we actually do a really good job at creating this. We do things like game jams and hackathons, and we have many different talks that show people how to do wonderful things in the development space. And we can also go and look at just billions of lines of code on sites like GitHub and see how people have done these things. Similar to the simulations, we can see how others do it, but also we have many free places on the internet where we can just build things for the sake of building them, give them a home for free, and then let them live as learning examples for us and for others. Now, I would be remiss to be giving a video game talk and not talk about my favorite game of all time. Tetris is one of these games that to me embodies the mindset of development. It's a puzzle game in which most of the time you're playing against yourself. This is actually me playing this game. Now, the hope of Tetris is just continual progression towards improvement. It's me playing the same game with different pieces every time, hoping for a better result. And that being said, one of the things I like about Tetris is that even when you line out, even when things are going bad for you, you just start the game over and you just try again. Again, in a world where development is cheaper than it's ever been, where development systems are cheaper than they've ever been, when paying for compute is cheaper than it has ever been, in many cases, you can get simple websites up and running for free. We're in a space where we often think it has to be perfect on the first time. And that's just not the case. You're going to get hairy messes, hairy situations that you got to solve, and then you're going to learn how to solve them. And you're going to just keep going until eventually you line out, and then you're going to start the game over. Nothing wrong with that. Now, what makes Tetris a great analogy for general development is in the game itself, you're often working to balance sustainability and performance. And the best part of this is the way that you do this depends on how you're playing the game. For instance, if you're playing in classic format, your points are designed based on the number of lines that you clear in a single turn. So you might often stack higher because you can gain more points as you clear more lines in a row. Whereas in a modern battle format, you often are playing against someone, and the goal is to often disrupt what they're doing as fast as possible, and they're trying to do the same, which means that you are working mostly to keep the area of play that you're in as clear and sustainable as possible. Now, there isn't a direct correlation to maybe web development or scientific development as I would like in this example, but I do think that there are some really good parallels to how you're building your code. How is your code going to be used? Are you working on a lot of difficult situations that could make your code hard to maintain over time? If that's the case, then maybe you write your code a little differently. Are you working for maybe small sets of large moves at one point? Then maybe it's okay to stack a little bit of complexity on. But understanding how you are playing or how you are developing is going to be the first key into significant development over time. Now, I hope that this talk has given you some inspiration into thinking differently about how you are building your projects and how you are designing your projects. Again, this wasn't meant to be a one-to-one parallel of play more video games and write better code. But I do hope that it challenges you to look at some of the things you're doing outside of your daily coding experience and gain insight from them that you can then take back into your lines of code and help you to become a more well-rounded and maybe a slightly happier and a more engaged developer. But as with most things, always remember, just like with video games, it's great to take breaks, it's great to stay hydrated, and more than anything, make sure that you're having fun in the process. Thank you.